In this lesson, we'll find the potential energy of a system using the concept of self energy and interaction energy. So here we have a point charge Q1 surrounded by a thin spherical shell of radius capital R having charge Q2. Now we have to find the potential energy of this system. A point charge does not have any self energy. So self energy is due to the thin conducting spherical shell only. And the self energy of a thin spherical shell is given by the charge squared, so Q2 square by 8 pi epsilon naught r. So this is the formula of self energy of a thin spherical shell, thin conducting spherical shell. Now we need to calculate the interaction energy. Interaction energy is given by any charge Q1, let us take, multiplied by the potential created by the other charge at this point. So Q1 into V12. So V at 1 due to 2. Now Q1 is Q1, potential created by Q2 at Q1. A thin spherical shell, inside is an equipotential and the potential is equal to potential at surface. So this will be given by 1 by 4 pi epsilon naught Q2 by R. So therefore, this self energy comes out to be, or interaction energy rather, comes out to be Q1 Q2 by 4 pi epsilon naught R. We could have calculated this by looking at the other charge also. So this interaction energy is also equal to charge Q2 multiplied by potential at 2 due to 1. So charge Q2, this potential at 2 due to this one will be equal to 1 by 4 pi epsilon naught Q1 by R, and therefore we'll get this as Q1 Q2 by 4 pi epsilon naught R. So this is calculated by two methods. We got the same answer. The total potential energy of the system is U self plus U interaction. U self is Q2 square by 8 pi epsilon naught R plus Q1 Q2 by 4 pi epsilon naught R. We can take 8 pi epsilon naught R as the LCM. Then we get Q2 square plus 2 Q1 Q2. So this method is simpler compared to the method using concept of energy density. We got the same answer by that method in the previous lesson. Self energy of a thin spherical shell, conducting thin spherical shell, is charge square divided by 8 pi epsilon naught into radius, and the interaction energy is Q1 into V12, where V12 is the potential at 1 due to 2, and that is also equal to Q2 into V21. V21 is the potential at Q2 due to Q1.